Example 3, use the quadratic formula to solve. X squared equals 3x plus 5. Now, before I actually write the quadratic formula up here, let me remind you that the quadratic formula we did last year, we derived it using completing the square process. And the original structure of the quadratic equation that we used to derive it was ax squared plus bx plus c equals 0. If a formula is created from a specific structure, that specific structure is needed to use the formula. So what we have is a descending order quadratic function equal to 0. So we need a descending order quadratic function equal to 0. So the first thing I want to do anytime I use the quadratic formula to solve a quadratic equation is get it in descending order equal to 0. That is the first priority. It will not work unless you do that. So make sure that you always start off with that step. All right? A lot of times they start off in the right form, which is great, but sometimes they don't. Just instead of even, let's say this is the problem in your book, instead of copying down the problem then doing this, just immediately copying on your paper in the right order with the right structure. That saves you a line on your paper. All right? Now, the formula itself says that x equals negative b. Let me use some different colors here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the formula. Okay, if, like me, you can just spout it off at the top of your head, don't feel the need to write it down all the time. If, on the other hand, you can't, you have to look it up on your formula sheet, write it down every time you have to look it up, eventually it'll stick, and if it ever disappears, you do it again until it sticks, and then it eventually won't go away ever. Now, if we consider the problem that we have here, considering this structure, what's in front of x squared is a, what's in front of x is b, and the constant is c. So, this is 1x squared, so a is equal to 1. This is negative 3, so b is equal to negative 3. And that's negative 5, so c is equal to negative 5. The original structure has a bunch of pluses up there. So if you see a minus, that represents a negative number. If you see a positive, that represents a positive number. So number and sign count. Very important that we pay attention, not just the number, but also the sign for each thing. Once you've identified what A, B, and C are, notice that the structure here has 3 specific pieces. We have change of sign on B, we have double A, we have B squared minus 4AC, which is probably the more complicated piece of the formula, but it's still just square a number and multiply and subtract, so it's not high-level stuff going on here. So let's start with minus B. What does minus B equal? 3. Whatever B is, change its sign. That's all minus B is or ever will be. Change the sign of B, whatever it is, always change the sign. What does 2A look like in this problem?
1, 2.
2A is equal to 2. 2A just means to double whatever A is. A is equal to 1. 1 times 2 is 2. Those two things are simple. You might not even want to write those down. You can do those two things in your head. Maybe you just want to figure out what this thing equals and then go ahead and write your structure. Make sure minus B goes there and 2 times A goes there. But if you want to write it down, it doesn't hurt. And then B squared minus 4AC. Now let me just say something real quick, and some of you are at fault for doing this last year, and it's not atypical. A lot of students do this. It's a very commonly missed piece to this formula. B squared is always positive. Always, 100% of the time. I don't care if B is positive or negative, B squared is always positive. Alright? So, what I do is, like usual, I'm going to square B in my head instead of writing down number squared. Saves me a step and gets me past that whole should it be positive, should it be negative question, because I'm not going to say minus on my paper. I just know it's always positive. So what's 3 squared? 9. Don't focus on the minus sign because B squared is always positive. Just square the number and you got your answer. Negative 3 times negative 3 makes positive 9. So it is 3 times 3. So just whatever B is, square it, write it down, and then it's done. Minus 4 times A, which is 1, times C, which is negative 5. Alright, so here's A, here's C, and this number 4 is just a magical 4 that's part of the formula. Alright, that 4 is always there. It had to do with when we did complete the square to solve the quadratic formula to make it, a 4 just showed up in our work. When we got a common denominator, that's when it happened. So that 4 is just part of the formula, let it be there. This is A and C. Notice A and C have opposite signs, that happens quite often. if A and C are opposite sign, notice this minus and this minus makes a plus. So this product here quite often becomes positive. The formula itself says subtract, but the multiplication changes it to an addition problem. That's pretty typical. It happens more often than not. Okay, 20 plus 9 is 29, so that's what b squared minus 4ac equals. So I've established what negative b equals, I've established 2a, and I've established b squared minus 4ac. So then I just write my answer. X equals fraction bar plus or minus square root. Minus b goes in this slot, which is 3. 2a goes in the bottom, which is 2. b squared minus 4ac goes inside the radical, which is 29. The last step is to simplify that answer as much as possible. Hopefully we can all see 29 is a prime number, does not simplify whatsoever. So that's the answer.
Yay.
All right. Now let me just give you a, for instance, because this will probably happen in the homework at least once. Suppose you got all that done and you ended up with x equals 6 plus or minus the square root of, let's say, 48 over 12. All right? The square root of 48 is 4 times the square root of 3.
And then you can
16 times 3 is 48, square root of 16 is 4. And then, go ahead, Tucker.
No, you can divide everything by 2.
Very good. This number and this number and this number all divide by 2. Don't worry about underneath the radical, worry about outside the radical. All three of these divide by 2, so then we can get 3 plus or minus 2 times the square root of 3 over 6. That's the best answer. All right, notice 3, 3, and 6, but that 3 is in the radical, so it doesn't count. So you can't reduce by 3. Only numbers outside the radical count. So that number, and that number are even, so you can reduce it. Suppose we get this answer. We work all the way through this, and we get x equals 2 plus or minus the square root of 36 over 4.
No, that is 6.
All right?
2 plus or minus 6.
So the square root of 36 is 6.
So 2 plus 6 is 8.
8 over 4
is
is
2. 2 minus 6 is...
Right?
Negative 4.
So, you see here? The square root of 36 is 6. Plus or minus 6 means to add and subtract, so 2 plus 6 makes 8, 2 minus 6 makes negative 4. In both cases over 4, because that's the number on the bottom. 8 over 4 is 2, negative 4 over 4 is negative 1. Okay? So we have the capacity to get down to nice pretty answers like 2 and negative 1. We can get a radical answer that can be simplified down to something smaller, or, again, we might just be done right there. If the radical doesn't simplify at all, the numbers in front, 3, 1, and 2, don't have a common factor. You can't do anything else to it, so you stop and you're done. All right?